everyone, welcome to this Azure Learn Live session. The session is about introduction to Azure DDoS Protection and Azure Web Application Firewall. My name is Soumya Mahadevaya. I am a senior product manager in the Azure Web Application Firewall product team, and I will be talking about Azure Web Application Firewall module. And now I will introduce my group presenter.
Hi, everybody. Great to be here and thank you for joining us. And thanks, Soumya, for the introduction. My name is Samir Dahan, and I will join Soumya in introducing Azure DDoS Protection for this session. So I wish us all a great learning experience. And say hi to our moderator, Vasilis, who will join us and will support us during this session. Hello, Vasilis. Okay, so here you can see the QR codes for those Learn Live sessions, and you can obviously take those sessions offline later and complete the learning modules by yourself. It's an interactive session, right? So we encourage you to ask questions, say hi, and make the session a great experience for all of us. And now let's move on and start with the introduction to Azure DDoS Protection. Our learning objectives will first explain distributed denial of service, which is DDoS. We'll talk about the attack types, the components of an effective DDoS response strategy. Then we'll compare the differences between Azure DDoS infrastructure protection and the priced offering of Azure DDoS network protection. And we'll also evaluate Azure DDoS protection features, capabilities, and some of the architecture options. So what is Azure DDoS protection? Before jumping in, let's talk a little bit about DDoS. DDoS attacks, what are they? So essentially, a DDoS attack is when an adversary tries intentionally to flood your systems or applications or networks with fake traffic, typically volumetric or a lot of traffic towards your application in order to take it down, in order to render it unresponsive. And there are like two main techniques to do so, right? So I would say that the first one is more easier and cheaper. So adversaries will either use some CLI scripts. Those are available in any operating system, so they can use that, or they can use DDoS as a service. There are such services or DDoS stressors, we call them, in the dark web or even publicly available in the internet, when adversaries rent those services for relatively small dollar fee, and they can easily launch DDoS attacks on your applications. What are the types of DDoS attacks? So we have like three main groups. The first one is volumetric attacks. Volumetric attacks, those intended to flood the network layer. They create a substantial amount of seemingly legitimate traffic or bad traffic in order to compromise the systems and networks so they become unresponsive. It doesn't really matter if those attacks are carried over UDP, or those are amplification reflected attacks, or the attacks are spoofed. It doesn't really matter. The main purpose here is to chunk or choke the network layer in order for the application to not get the traffic from legitimate user and then becoming unavailable for the end users. The second group is protocol attacks. These attacks typically target layer 3 and layer 4 layers in the OSI model. And the main idea here is to exploit weaknesses in layer 3 and layer 4 protocols, such as TCP. A good example would be TCP SYNFLOOD. This attack exploits part of the three-way handshake, or how TCP actually establishes a connection. In this attack, the attacker sends a succession of TCP SYN requests, ignoring the TCP SYN ACK replies, which means that the attacked application or server starts to open TCP session for each such TCP SYN request, but never completes the 3A handshake authentication. And in this case, it means that the memory is getting consumed, right? So at the end of the day, if the attacker will send many TCP SYN requests with from spoofed IP addresses, for example, it will create a lot of half-open TCP connections on the attacked application, and at the end of the day, the memory resources will deplete, and the server will not be able to accommodate real TCP SYN requests from legitimate users. So this is the protocol attacks, which is the second group of DDoS attacks. The third one is what we call resource or application layer attacks. Those attacks are actually targeting the top layer, or the layer 7 in the OSI model. And the intention here is indeed to either flood the server with, if we take, for example, web applications with HTTP flood attacks, or there are also type of low and slow attacks on layer 7 for HTTP. As an example, an attacker may open HTTP connections with an application, but will not close them, and will keep the connection up and running, sending a small amount of traffic in order for the server not to terminate the session. And in this case, again, it will deplete the resources. So it is either flood attacks like HTTP GET or POST request of flood attack, as well as low and slow attacks that are coming at the application layer. So to sum it up, right, we have like three groups of attacks. We have the volumetric attack. This is used to choke the network layer. We have protocol attacks. These are in layer 3, layer 4, and those are used to take or exploit weaknesses in protocols like TCP. And there are layer 7 attacks, which are either volumetric or what we call low and slow attack, targeting HTTP, for example, in the case of web applications.
So, Amir, as you explained very well, the DDoS attacks happen at layer 3, layer 4, and layer 7. What layer does Azure DDoS protection cover?
Okay, great question. So Azure DDoS Protection Service is focused in volumetric attacks and protocol attacks. So we actually cover attacks from layer 2 to layer 4, and we'll detect and mitigate those attacks automatically, as we will describe. But resource application layer attacks, specifically towards web applications, and you know that, Soumya, because you're going to explain how to protect against these kind of attacks, those attacks should be protected with Azure WAF, or Web Application Firewall, as you will cover later.
Thank you.
Next, let's talk a little bit about DDoS infrastructure protection. So DDoS infrastructure protection provides continuous protections against DDoS attacks for all Azure resources and generally Microsoft online services, right? It protects the platform, it protects the infrastructure of Azure as a cloud platform serving customers hosting their application. It actually works in totally automatically. It monitors traffic always on, and detects attacks automatically. And when the attack is detected, it will kick in mitigation automatically as well. And the detection and mitigation is something that we do as part of our infrastructure protection for all resources in Azure, and those are being done automatically. The infrastructure protection service level agreement is best effort support for those customers that are not enrolled to our DDoS protection SKUs, as I will cover next. So infrastructure protection provides continuous protection with active traffic monitoring and always on detection focused at protecting the Azure platform itself.
So Amir, I have a question. Customers understand that Azure DDoS protection is a priced offering. So why should they care about Azure DDoS protection when Azure protects them for free?
That's a great question. So I would say that yes, indeed, Azure DDoS infrastructure protection is offered to all customers hosting application in Azure, but its main focus is to protect our infrastructure or protect the Azure platform. But remember, since Azure is massively scaled cloud platform, the detection triggers we set to protect our infrastructure or our platform are very high. So there are very good chances that when there is a DDoS attack directly targeting an application, that attack will go below the radar and hit the application directly and will actually bypass our DDoS
Mhm.
infrastructure protection. And this is the reason why we essentially recommending to each and every customer hosting application in Azure to enable DDoS protection in order to protect their application specifically. Next, so we talked a little bit about Azure infrastructure protection, which is a free offering to all of Azure customers. But now let's talk about Azure DDoS network protection. This is a priced SKU that is available to customers to consume. And now I want to describe a little bit the value added capabilities and features that it provides to customer on top of infrastructure level protection. So first of all, few words about Azure Global Network and the way we actually mitigate attack at high scale. So Azure DDoS network protection is globally distributed. We have like massively mitigation capacity distributed worldwide so that we can mitigate not only the highest attacks in history, and we've published 3.5 terabits per second attack last year that we mitigated on one of our customers, but it also ensures that we can mitigate thousands of attacks in parallel. And in fact, we actually mitigate 2,000 attacks on average per day in Azure as part of our global network and global mitigation pipeline. So this is one point to consider, the scale. The second point is, what does it mean to actually enable Azure DDoS network protection? It is very simple. The only thing customers need to do is first to create a DDoS protection plan resource and then go to the VNet that he wants to protect and enable DDoS protection on that VNet. Once this is done, we will start automatically to monitor your virtual network, monitor the resources, and apply detection and mitigation without user intervention. This is straightforward and very easy to configure. You don't need to add any service, any networking component. You don't need to change your networking or routing infrastructure within your VNet. You don't need to do anything. Everything is an overlaid service that we apply that actually monitors attacks and detects attacks. Third point, native integration with Azure Portal. The fact that Azure DDoS network protection is a natively integrated service within Azure Portal, and the fact that it's a native Azure service means that once you enable DDoS protection on a service, we can actually gather all the needed resources for you. You don't need to select beyond selecting the VNet to protect. You don't need to worry about whether the firewall is protected or the load balancer or my VMSS cluster or my Azure WAF or whatever. We do that for you because we know to identify the resources automatically and apply detection, mitigation, as well as monitoring analytics as logging for them. We have very rich integration with Microsoft Defender for Cloud as well as Microsoft Sentinel. As an example, right, we've just released a new Sentinel solution for DDoS, and these solutions provides customers with a data connector. It provides customers with a workbook that is used for analytics. It provides analytics rules that you can use to, create incidents automatically, and then it actually allows you to kind of enrich your SOAR, your security orchestration and response more effectively. And on the Microsoft Defender for Cloud, we have recommendations as well as alerts. So when there is an attack coming in, you will get notification. And when the attack is mitigated, you will know that as well because we will notify you. On the recommendation side, when we understand that a virtual network is not protected, you will be notified on that as well. So you can make the correct adjustments on your side.
So, Amir, some people see that the risk of a DDoS attack is lower than, for instance, data theft or other types of cybersecurity attacks. So, why should the customers care about protecting against DDoS attack? I mean, an unlikely event that it may happen.
Yeah, so that's a good question. So I would say first of all that DDoS is like a backup system, right? A backup system, you use it, when you want to prepare for a disaster recovery. You must have your data ready for retrieval when there is a disaster, right? DDoS is the same. You don't want to wait for the moment when there is an attack hitting your application, rendering it unavailable. This may impact your business, your revenue, your reputation, and it's something you want to get prepared for. So DDoS protection makes sure that once there is an attack, you will be safeguarded against it. Now, also depending on the exact, I would say, application category or how mission critical the application is, the more mission critical, the more you need DDoS protection. So e-commerce applications or any application that uh, needs to make sure that is available in order to support the business continuity, those types of applications need DDoS protection. Next point I want to highlight that is one of the additional benefits for DDoS network protection: cost guarantee. Cost guarantee, it's not a technological feature, but it's a great value added capability that we offer to network DDoS protection customers. So cost guarantee means that when there is a DDoS attack, due to its volumetric nature, there may be cases where the application will scale out or there will be an excess network bandwidth resulted from the application. And it doesn't really matter what happens as long as there were directly derived from a DDoS attack that customers can actually point us to. If this is the case, we will prevent excessive billing. Actually, customers will get refunded 100% for the fees that otherwise they will pay if they are not protected by DDoS network protection. So this is like a sort of insurance policy, right? You buy an insurance policy, and it is beyond the technological capabilities of DDoS by protecting your application, etc. We also make sure that any excessive billing will not take place, and you will be credited against those. Another really important capability is what we call DDoS rapid response. We've actually established a DDoS protection rapid response team, and this team stands 24/7 up and ready to support customers during real life attacks. With DDoS, when there is a DDoS attack, it is like, a red flag. Customers want to make sure that the attack is mitigated immediately. They don't have time to go and investigate the attack, do fine tuning. They want it to get stopped. And this is the purpose of DDoS Rapid Response Team. With DDoS Rapid Response Team, customers can easily go into portal and then following steps 1 and 2 here, open a support ticket, which is with critical severity and mentioning it is uh, under attack, and they will get a 15 minutes SLA since from the time they open the ticket until someone from the DDoS rapid response team will get online with them, supporting them to mitigate the attack. And we do need to help customers mitigating the attack, specifically for those cases where the attack vectors are evolving and changing. And well coordinated attacks are those attacks where the adversaries will try to bypass mitigations by continuously changing the attack vectors, and we will be there to support them in real life.
So, Amir, do you have any real life examples of why rapid response is so important without giving out any customer information?
Yes, definitely. So there are a lot of cases where we go, with rapid response, we go and helping customers to mitigate attacks. So I can give you one example from like 2 weeks ago that I was part of. There was a coordinated attack targeting a specific application to one of our belonging to one of our customers, and with report DDoS rapid response, we went online supporting the customers. And what happened is that the attack was coming from a botnet consisting of thousands of sources, and the attacker continuously increased the attack sources in order to bypass the mitigation. So what we did here is supporting him in the following way. He knew that in peacetime, his customer base is located in specific regions worldwide or even countries. So he asked us to block traffic coming from other countries that he suspect not having any legitimate end user accessing his customer. And we applied this policy. We fine tuned his DDoS protection policy in order to support this ask. But we do a lot of other fine tunings in order to support our customers. And you need to remember this is happening in real life. Every minute that passes on, the customer application is impacted, its availability is impacted, and the business is losing money, right? So we need to act very fast, and this is where rapid response shines. Let's double click a little bit on how Azure DDoS protection pipeline works from the moment the customer provisions the service until we do the detection and mitigation. So here you see like two flows. The upper one is the customer that goes through the provisioning process, and the lower one is what happening during attack. So starting with the upper one, a customer goes to Azure portal. As I mentioned, he creates a DDoS protection policy. He then goes simply and apply this policy or enable DDoS protection in each virtual network he wants to protect. From the moment he does that, at the backend, we are going to create policy, a DDoS protection policy for each and every resource in the virtual network that is accessible from the internet. And this policy is going to be the baseline for us to detect attacks. So once we have this baseline, we are going to monitor traffic anomalies or attacks towards the application. Moving on to the lower part of the figure, when the attack is coming in, we are actually finding the anomaly and then kick in the mitigation. Once we kick in mitigation, we are going to take the traffic, scrub it, and the result will be that the bad traffic or the attack traffic will be mitigated, and only the clean traffic will be forwarded to the application or the customer virtual machines or whatever the application is built on. Few words about, I would say, our secret sauce. Okay, what makes DDoS protection service effective is what we call adaptive tuning. We have in our backend an adaptive tuning engine, which is built from multiple algorithms, machine learning based algorithms that are actually creating the policy, the baseline policy I just mentioned. And this is how we make sure that, first of all, the attacks are detected and then accurately mitigated. How do we create those policies? The policy essentially reflects the fingerprint of the application. It's like a human fingerprint. It's something specific to the application we are protecting. Each application will have a different fingerprint, and so it will have a different DDoS protection policy that we will apply to protect it, right? So it gets actually two inputs. The first one is representing the application posture. How many, for example, how many virtual machines at the backend are used to construct the application, right? And the second input is the traffic baseline in peacetime. So we want to know how traffic looks like in peacetime when there is no attack. And we are looking on various attributes and parameters in the traffic to characterize it. Once we have these two inputs, we are injecting those into the adaptive tuning engine. And this one will actually result in establishing a DDoS protection policy for each and every application that it protects. Few words about monitoring, analytics, and logging. So only Azure DDoS network protection customers enjoy these capabilities. Infrastructure level protection is there, as I mentioned, to protect the platform. We don't provide customers with indication of attacks, mitigations, or how and if their applications were affected by DDoS, right? But for Azure DDoS network protection customers, we provide rich capabilities. So our monitoring capabilities are part of Azure Monitor. We provide telemetry and metrics. Those metrics are capable of showing the DDoS protection policy that we apply, what are the detection triggers. They can show you also what is the traffic that we are dropping, what is the traffic that we are forwarding to the service, and on top of that, we provide a rich level of logging information that customers can ingest with into SAM systems. It can be Microsoft Sentinel or any third-party SIEM system, and this can be used for them to investigate what happens during an attack and decide on what are the next steps for them to fine-tune their DDoS protection policy with the help of us if they need to do some changes or to decide on what they need to change in their DDoS protection strategy. And this is something that is also provided. And on top of that, customers can obviously create various levels of alerts, either through Azure Monitor or with our integration with Microsoft Sentinel, and those are provided natively through Microsoft Defender for Cloud. In the screen here, what you see is what we provide as a workbook for Microsoft Sentinel. It includes a lot of information, like you will see what are the attack vectors. You will see what are the attack sources and what are the attack destinations. You will get breakdown information and traffic statistics on the attack vectors themselves. And you can deep dive and see a lot of additional information throughout the workbook that you can consume again through Sentinel or even through Log Analytics if you don't have a Microsoft Sentinel service enabled. Okay, I think we've covered how Azure DDoS network protection works, what are the value added features and capabilities. And in each and every DDoS response strategy, part of it is to make sure that the DDoS protection is set accurately enough and it's going to mitigate attacks effectively when they arrive. And the way we support customers in doing so is to allow them to test our DDoS protection service, right? The way we do that is partnering with leading DDoS simulation partners. Those are listed in our public documentation, so you can take a look at them. And those partners will help you to test your DDoS protection service before you apply it in production. And here I want to show you a quick demo on how you can do that with one of our partners. So let me please double click on that. So this is one example. This is Ixia Breaking Point Cloud. It's one of our testing partners for DDoS. And what you see here is a self-service portal that Ixia provides our customers with that our customers can use to simulate DDoS attacks on resources in Azure. Obviously, any registered customers will be authenticated and validated so that we are going to make sure that any public IP that is going to attack is actually belonging to an Azure subscription he owns. And there is a whole process with Azure Active Directory that is going to verify that before customers can launch attacks. But let's assume it's authenticated and everything is fine. What customers can do, they can select the IP address they want to attack, and this will be a public IP resource in an Azure virtual network they want to attack. They configure it, they set the port, and then they select the DDoS profile. This is essentially the attack vector in layer 3, layer 4 that they want to attack. They can select a SYN flood or a UDP flood or even a sort of reflected attack flood based on memcached. They can also set DNS floods. Once they set the flood, they can then move on and decide what will be the test sites, which means what will be the volume of the attack simulation they are going to create and how many source IPs will participate in this attack. And then they decide on the attack duration. The next step is just simply to click Start Test. Everything is going automatically from now, and at the end of the day, they will get a result which you won't see here because this IP address is not authorized by Breaking Point in this example, but otherwise you will see results with the effectiveness of how we protected the resource against the simulated attacks with a report that describes what exactly happened during mitigation. So going back to my presentation, now I want to kind of summarize the differences between Azure DDoS infrastructure protection, which is a free offering to any customer hosting applications in Azure, and Azure DDoS network protection, which is a priced SKU that customers can use. So as you can see here, right, Azure DDoS infrastructure protection essentially provides automated monitoring of traffic, detection of attack, and automatic mitigation. But customers are not getting any indication of what's happening. And more importantly, The DDoS policy that we set for applications that are covered by infrastructure level protection is again very high. So application targeted attacks will go below the infrastructure protection radar and will get into your application. And the only effective way to make sure that your application is not being attacked will be to use Azure DDoS Network Protection, which will allow you to have the adaptive tuning engine as well as our all other capabilities and features that I've described previously. Okay, so I think we finished with the theoretical part, and now let's move on to a quick knowledge check. One second. Here it is. Okay, so we have like three questions. I give you 1 minute per question. You can see the QR code that you can, scan with your mobile phone. You don't have to no look at a different screen and answer the questions. So the first question here would be, which layers of the OSI model do DDoS protocol attacks target? Let's answer those, right? Which layers of the DDoS OSI model do DDoS protocol attacks target? I see the answers coming and I must be a very bad presenter. No, no, my mistake. I'm a very good one. I'm a very good one. All responses until now are good. Go ahead, move on. Okay, so the right answer is B. And we have 100% of the voters responding correctly. The answer is network layer 3 and transport layer 4 layers. This is what the DDoS protocol attacks target. Next one. Which Azure DDoS protection service offers DDoS rapid response support? A. DDoS network protection. B. Azure DDoS infrastructure protection. C. This service is not offered with Azure DDoS infrastructure protection or DDoS network protection. Again, you can scan the QR code and poll. Okay. Yeah, so the answer is DDoS network protection. This is the SKU that offers rapid response support. Last question. Question 3. What should an administrator do with the data logged during a DDoS attack? A. Discard this data when the attack is over. B. Use this data to analyze the attack. And C. Immediately clear your logs during the attack. Please vote. Yeah, good. Excellent. So the answer is use this data to analyze the attack. You don't want to clear it. You don't want to discard it. It's a valuable asset you have to understand what's happening and how to protect yourself better in the future. And now I would like to pass the ball to my colleague Soumya for the Azure Web Application Firewall learning module. Thank you.
Thank you, Amir. and welcome to the introduction to Azure Web Application Firewall. Um, One second, I'm just going to get started with presenting my slide. Okay. So in today's session, these are some of the learning objectives. First of all, we will understand what Azure Web Application Firewall is, some details about the Azure WAF. We will look at some use cases which will describe whether this Azure WAF is the right solution for you. And finally, I will describe a demo which shows how Azure WAF protects your web application from a SQL injection attack. So, first of all, what is Azure Web Application Firewall? This is an Azure service that protects against common web attacks. It's also called as Azure WAF, and you may hear me saying WAF a few times. But this service protects against web attacks like SQL injection attacks, cross-site scripting, and other attacks that extend beyond the OWASP top 10. OWASP is Open Worldwide Application Security Project, and this project describes all the various web attacks. But Azure WAF can go beyond that and also detect malicious bot attacks, API attacks, application layer DDoS attacks. So that is the overview of WAF. So once you have a web application, it could be an Azure web application or any other web application on the internet, you can be sure that malicious actors are trying to probe your application for vulnerabilities so that they can exploit your web. That's the reason why it's important to protect a WAF in front of your web app, because the WAF can protect against bots, crawlers, scanners that is trying to probe your applications, or it can also protect against web attacks as well as DDoS attacks. Now I want to touch at a high level what are the key features of Azure WAF. So at a very high level, the WAF constitutes managed rules. These are rules that WAF uses to detect various web vulnerabilities. So this is a combination of various rules, and the rules are maintained by Microsoft security team. And if any of the rule changes, then we notify customers and we update the WAF automatically. Also, we have bot rules. These are the rules which looks at malicious bot traffic. We can categorize the bot traffic and block the bad bots. And bad bots are detected using Microsoft Threat Intelligence feeds. Thirdly, we have got custom rules. If the managed rules and bot rules are not sufficient for your organization, you have ability to create your own custom rules for your own use case scenarios. Also, we have two modes of operation. The first one is a detection mode, which only logs request, and second one is a prevention mode, which both logs as well as blocks that request. Fourth, you have got exclusions. In exclusions, you can set up certain parameters that you want Web Application Firewall to omit from inspection. And this may be needed in certain cases when there's a false positive. And all these parts that I talked just now constitute what we call as a Web Application Firewall policy. And you have capability to assign this WAF policy at various levels so that you can manage it easily. We also have request size limits. These are size limits for the request header, the request body, the file upload size. So depending on the limits, you can configure WAF to trigger flag requests. Finally, we have got WAF that is integrated with Azure Monitor. With Azure Monitor, you have rich investigation logging capabilities, but you also have access to real-time alerts.
A question here, Soumya, please. So, and on the managed rules. So I understand these rules are actually maintained by Microsoft, right? So how customers are notified when there is a rule that is changing, and do they need to actually take any action in such a case?
Yeah, that's a very good question, Amir. So, you know that exploits are changing, they're evolving every day. So, Azure WAF team, along with Microsoft Threat Intelligence team, create new rules. And these rules constitute a part of a rule set change, and they're automatically updated. So, in the regular rule set updates, the customers just need to assign that rule. And depending on their needs, they may need to like set the correct actions for that particular rule. um, but there's an exception to this, and that happens whenever there's a zero-day vulnerability detected. For these rules, what we call as CVE rules, they are automatically deployed by Microsoft, and and depending on the severity of the CVE, they may even block that attack by default. So at that point, customers do not need to take any action. So that is how
Okay,
we enable it to be done seamlessly.
great, great. Thank you.
Sure. So one thing I want to talk about here is like once you have got managed rules, you cannot modify it or delete the rule because it is managed by Microsoft. But however, there may be situations when you have you're seeing that certain rule is triggering a false positive, and you don't want a legitimate traffic to be blocked. In such situations, you have ability to create an exclusion, or you can disable the rule.
And in this case, Somya, so how do you really decide if you should create an exclusion or disable a rule?
Sure. So exclusions are actually very granular by nature. So you have ability to look at a certain parameter of the HTTP request, for instance, a cookie parameter or a post args. And depending on that particular parameter, you can create exclusions that you can make sure that WAF will omit that parameter from inspection. So this will make sure that you do not completely stop completely a rule from monitoring, because if you disable the rule, all the benefits of that rule will be gone. Whereas with exclusions, you can make sure that the rule is still there, but only certain parameters are omitted from inspection.
Thank you.
Now, I want to pivot a little bit and talk a little bit about the application layer attacks, some common web attacks. So there are a wide variety of attacks, and I will not go through each one of them, but I want to touch upon a few important ones. Cross-site scripting is a very common web attack. In this case, the malicious actor sends malicious code to another user's web browser. Now, in this attack, it's not the web application that is the target of that attack, but it's actually the users of that web application who are the target. Some example I want to give you here is which happened with British Airways website by an actor group called as MageCard. This actor is known for credit card skimming attacks. So especially in credit card skimming attacks, once the actor has access to credit card information, they continue with identity theft, they do fraudulent purchases and various other harmful activities. But in this case, with what happened with British Airways is that the attacker noticed that there is a vulnerability in the JavaScript that is on the British Airways website, and they went ahead and modified the JavaScript to send data to their own malicious server. And once an unknown user, they did not know that link is coming from an attacker because it looked very familiar and it looked like it's coming from British Airways. And when they clicked on it, the traffic went to the malicious attacker's server. And the malicious attacker got access to all the session cookies, the session data, and other sensitive information. And that's how they conducted credit card attacks. Another example is a Yahoo email attack. This happened wherein a malicious actor created an URL which looked very similar to coming from the MSNBC news site. So, and when the users got this link, maybe through a phishing campaign or some other campaign, they clicked on it thinking it's MSNBC, but it's actually that link linked back to the attacker's website. And they got all the contact information of this user, the victim user, and sent this email, this malicious URL to all the contacts. And this became a self-propagating email war. So that was one of the examples of cross-site scripting attacks that we have seen in the past. Now, another attack is local file inclusion attack. Basically, in this case, it's usually seen most often in PHP scripts. The attacker creates malicious URLs, which will basically trick the web application to expose files that are on the web server. In this example I've provided, the good URL is trying to access the contact, but the malicious actor would craft a URL which would look like example.com question mark module HC password. And when that URL would trick the web application to dump out all the contents of the HC password file. So that is an example of local file inclusion. We also have other types of attacks, but the next one I want to focus on is a SQL injection attack. So this is a classic example of a SQL injection attack where the web application is not sanitizing input. When I say sanitizing input, it's basically a web application has a form, like it could be a login, payment, sign up type form with the username and password fields. But the web application does not look at the inputs that are coming in this form fields and blindly tries to give access. So that is an example where a malicious actor can create a SQL injection attack. In this particular case, we have a web app that is in front of a SQL database. And in the input form, legitimate user, would give a username as support with a password of 1234 ABCD. And the web application would then convert this into SQL variable as select star, where users is support and password is this. And if there was a record in the SQL database for this username and password, the user would get signed in. Now, what a malicious actor would do in this case is in the username field, they would give admin hyphen dash dash and leave the password field blank. And the web application would then convert it into this variable, SQL variable, where you have where username is admin hyphen underscore hyphen dash dash and then password as blank. And they would actually try to log in this malicious user as an admin. Basically, because in the SQL world, anything after double dashes is considered a comment. And that is why the web application would think this is an admin. And if there was a record for an admin user, the malicious actor would be granted access to the database. Of course, once they're logged in, they can go ahead and create a whole bunch of harmful activities like dropping the tables or creating new records or other types of SQL attacks. That is one of the reasons why it is important to have a WAF in front of web applications to sanitize the input, because application WAF, Azure WAF looks at this as a SQL injection attack based on the username password and blocks that attack and protects the web applications. So now that we have an overview of the WAF and some common attack details, I want to touch a little bit more details about Azure WAF itself. In this section, you will understand what are the different deployment models that Azure WAF currently is available in. What does a manage rule means? What does bot rules mean? How does custom rule work? And finally, we'll talk about the different modes of operations. Now, this slide talks about the current two deployment options for Azure WAF. The first one is you can have WAF integrated with Azure Front Door, or you can have a WAF integrated with Azure Application Gateway. Now, Azure Front Door is a global content acceleration delivery caching service, and it is deployed at the network edge at 118 edge locations across the world using an enterprise-grade WAN network. It provides TLS terminations and acceleration using anycast routing. Now, integrating Azure WAF at the front door provides protection to your network edges. We also have Azure Application Gateway. This is a regional load balancer that is deployed in the Azure regions in the data centers. Application Gateway has session-based cookie affinity, load balancing, and SSL termination. WAF integrated with Azure Application Gateway will ensure that the regions in the Azure regions are protected from web attacks.
Question here, please. So Soumya, so customers, do we give them the option to select every SKU for Azure Front Door and the Azure Application Gateway to use with WAF, or we recommend specific SKUs for WAF?
Yeah. So with Front Door, our current recommendation is to use Azure Front Door Premium. That is a SKU that we recommend. We also recommend you to use the latest version of Managed Rule Set, which is DRS 2.1, which has the highest level of threat intelligence rules plus the latest OWASP 3.2 version rules. On the application gateway, we ask you to use WAF V2 SKU on the app gateway and use the CRS 3.3.2, which provides the latest which has the latest rules for the WASP uptime. Plus, it has a new WAF engine, which has great scale and performance improvements.
Okay.
Sure. So now I want to go towards the manage rule set. This is a pictorial representation of our WAF manage rule set. It does not have all the rules, but this is a subset of the rules that we've got. As you can see, Microsoft default rule set is the main construct. Under the default rule set, you have got rule groups as well as various rules. There are the rule groups represent a particular a protection against a particular exploit, and there are many rules within a rule group to protect against that exploit. And on the rule group level, we have three main sections. So the first one is we have the Microsoft Threat Intel rule group. These are the rules that are generated by a team of Microsoft Threat Intelligence experts. And this is constantly updated as and when new exploits are coming into the picture. It's constantly updated. We also have the Threat Intel CVE rule groups. These are the zero-day vulnerability rules, protect against zero-day vulns. And then finally we have the OWASP core rule set that is coming from ModSec core rule set engine. So all these kind of constitute the manage rule set. We have ability to turn on different actions for each of the rules. Of course, there has default action, but we do have ability to turn on actions at a per rule level. And you can also enable or disable the rules at a per rule level. Now we have got bot rules. In this rule set, basically we look at malicious bot traffic and then we are able to categorize the traffic as good bots, malicious bots, or unknown bots. So these bad bots or the malicious bots are detected using Microsoft Threat Intelligence feeds, and we also have our own proprietary WAF rules. The bad bots are blocked by default, whereas good bots, which are search engine crawlers, are allowed by default. And then we have a whole bunch of other type of bots which we have a little bit lower confidence on, or they are general purpose HTTP clients or SDKs which are considered as unknown bots. They're currently left in log mode, but you have capability to change all the actions at a per rule level. So all the manage rules and the bot rules that we talked about right now, if it is not enough for your applications, for your use case scenarios, then you can craft specific custom rules. And we have huge amount of customization that is available for you. And the match type, we have got geolocation, IP address, size, string match types. These are the four main match types. And then we've got variables like request header for the string match type, which looks at the HTTP request itself. You can match on various variables like the query string parameter or the URI parameter or the cookies. And then you can use specific operators like the equal, any, rejects operators. And once the match has happened, you can allow block, log, or redirect as an action. So this is a very good capability for you to create your own custom rules for your own applications. Now I want to touch a little bit on some of the key custom rules. The first one that is an important custom rule is a geo-filtering rule. Basically, in this, what happens is you may have traffic coming from a certain country which you want to block. Then you can create a custom rule with just a 2-letter country region code of that country. And whenever WAF sees an incoming IP address from that country and it matches the custom rule, it will block it if that is what you want to do. So that is one of the reasons you want to use geo-filtering rule. Also, it is possible to chain the custom rule. Say, for instance, you don't want to block every traffic coming from one country, but there is a certain HTTP request you want to block from one country, then you can have multiple custom rules in multiple operations in one custom rule, so that a particular HTTP request with a certain parameter from a certain country is blocked. So you have a wide amount of customization in this case.
So yeah, if I want to block a specific country, for example, but this country is not listed in the custom rule, how can I do that?
Okay, yeah, Azure WAF always strives to have all the countries listed across the globe, but there may be times when a certain region or country is not listed. In that case, we have capability to use unknown country code of ZZ. So any traffic that matches that particular country code or region code will match, and you can still have custom rules based on that. Okay. So the next custom rule that I want to kind of touch upon is IP restriction rule. In this case, usually the web application firewall is open to the internet, but you may want to restrict access to your web application from a certain IP address or a range of IP addresses. That's when you want to use IP restriction. And by using this IP restriction, you can now control access to your web application to a certain range. Another important one is rate limiting. This is the where, like what Amir was saying, we can protect application layer DDoS attacks using rate limiting rules on the custom rules. So basically, it's very easy to configure rate limiting. You just have to specify a rate limit duration, or this is the counting period, and then you have a threshold in that counting period. And if the traffic rate goes above the threshold in that counting period, the traffic starts getting blocked. Of course, you can change the action as you wish, but that is the high-level overview of rate limiting access control capability that we have got today. We have seen many HTTP flood attacks, cache bypass attacks, and other type of DDoS attacks protected using this rate limiting operator custom rule. Now I want to come into the two modes of operation. So Azure WAF has two modes. The first one is the detection mode. In the detection mode, Azure WAF logs the request but allows the request to go through. Whereas in prevention mode, Azure WAF logs the request but does not allow the request to go through.
So my question. So I understand prevention mode, right? Because if you want to mitigate attack, this is the mode you should use. But why should customer use detection mode if it doesn't mitigate the attack?
That's a very good question, Amir. So actually, what WAF team recommends is that you should have a staging environment or a test environment where you turn on the WAF first in detection mode. Here, the WAF is not blocking your request. It just logs the request. And this is how you can make sure that the traffic that is passing through the WAF is actually working as expected. So in detection mode, there are two things that you can try to look for. The first one is false positives. In what we mean by false positives are these are legitimate traffic that is getting blocked by WAF. Or you can have a false negative. That is, we actually have a malicious traffic, but WAF is not protecting it. So in detection mode, you can test for these two type of false positives and false negatives and make sure that the WAF is working correctly. You may need to create exclusions. You may need to do various other things to ensure that the WAF is working as is expected, and then turn on that WAF in prevention mode for your production level traffic.
Okay, got it. Makes sense. Thank you.
Sure. Yeah. Now I want to look into some of the details of Microsoft Sentinel integration with Azure WAF. So Microsoft Sentinel is the SIEM solution, and it is used for all the types of logging, monitoring, incident investigation, and other type of playbooks. So on the left side, you can see the data connector that it's an out-of-the-box Azure WAF data connector that we have created for Sentinel, and it pulls in the logs for both application gateway as well as the front door logs into Sentinel using log analytics. And once the data is in Sentinel, then you can have access to all the features, functionalities of Sentinel. In the middle of the screen, you can see our Sentinel analytic rules. These are the rules that we have got created in Sentinel to protect against XSS as well as SQL attacks. And these apply for both application gateway as well as front door. Once these analytic rules are triggered, you can generate incidents in Sentinel and you can then investigate further. And on the right side, we have got the notebook, which we just recently released. This notebook takes on the Azure front door logs and looks for SQL injection attacks. And once it finds SQL injection attack, it guides the user through an automated investigation process. And if the investigation determines that this incident was actually a false positive, it will create WAF exclusions using WAF APIs automatically. And the final integration that I want to highlight here is the workbook. This is the Microsoft Sentinel workbook we have for Azure WAF. In this workbook, it provides a holistic view of your WAF policies. You can filter on the different type of actions that the WAF is executing on. It has a list of top 40 blocked URIs. It talks about the different rules that were hit, what are the attacking IP addresses, which countries those IP addresses are from. So all these type of visualization is available with Microsoft Sentinel Workbook. So now that we understood what Azure WAF looks like and what are the integrations, now I want to pivot a little bit into the details about when you think a WAF is needed for your scenarios. So we will look at different use case scenarios and we will try to see if it makes sense for your customer operations applications. The first scenario that we have is that you have got web applications that have sensitive or proprietary data. An example of this is you have a payment site. You may have credit card information, you may have other personal information of the users like passport information and other type of secret data. And you're motivated to protect your users' data. If for some reason a malicious actor got access to your web application and they broke into the application, once they have credit card information, they can do identity theft. They can make fraudulent purchases or siphon off rewards. Or the worst case scenario is they can actually sell this data on the dark web or hold your company at ransom. To protect against all these type of attacks, it is important that you use a Azure WAF to protect against these type of web attacks against your application. Another scenario is you've got a login sign-in type scenario. Here, the web application attackers are trying to log into your account. There's a whole bunch of leaked credentials available in the dark web, which if the malicious attacker gains access to it, they may log into your web app. Once they're logged in, they may even elevate the privileges as an admin, and then they may able to execute various commands. They may download malware. They may create a command and control center, and then execute more commands, which could be harmful for your application. They may even use credentials to sign into other sites and services. So that is why it is important to have a WAF in front of your web application which has sign-in forms. One thing to keep in mind here is that you need a multi-pronged network strategy for this scenario. So that may include you may need to have strong passwords, or you may even have multi-factor authentication like the phone authentication or the text SMS authentication as well. One more scenario is that your team does not have security expertise. It requires a lot of security expertise to understand the structure of HTTPS requests, how the various exploits occur, how the HTTPS request is exploited. You may need to know query strings, user agents. You may also need to understand front-end server-side technologies. So that is when it makes sense to have a Azure WAF, because Azure WAF team is backed by 8,500 security experts, and we have rules that are constantly developed for against different new exploits coming up. So it makes sense to have a WAF in such scenarios. It's unlikely that your company is in the process of developing security code. You probably are developing a product or you're trying to give services. In that scenario, it is necessary to have Azure WAF so that you can offload that work to Azure WAF. And also the coding for coding in-house for security exploits is expensive because the web developers with necessary security expertise are rare and expensive. And also this is not a one-time activity because exploits are constantly evolving. So you need to have a group of experts who are constantly developing new rules. So it actually may be cost effective sometimes to use Azure WAF. And you may also have a proof of concept or a minimum viable product. And it's not cost effective for you to hand code security code. In that case, it's necessary to use Azure WAF to protect against your apps. And lastly, you may have a web app launch. The marketing team may be getting ready for a launch, but an attacker may know about your application launch and then they may try to disrupt it. That's one of the reasons you may want to have a WAF in front of this app to protect against your launch. So those were some of the scenarios that will be helpful for you to understand if WAF is the right solution for you. Now I want to give you a short demo that describes how Azure WAF protects a website against SQL injection attack. This is a high-level pictorial representation. of the demo, we have got a global WAF that is integrated with Azure Front Door, and then we have got a website that is actually protected by Azure WAF, and we have we have an attacker and we have a legitimate user. And I also want to describe this concept of Azure Private Link. Azure Private Link is another Azure service that creates private endpoints so that those endpoints are only accessible from known products. In this case, the private endpoint is a website and that is only accessible through the front door, and it is not accessible through the internet. So by using the Azure WAF, which protects against web attacks, and the private link, which protects against internet attacks, you can have a very secure solution for your WAF. Now, let's see how this solution works. This is my Azure Front Door Premium solution. We have got a front door profile, and I've already configured it in the interest of time. So basically, the front door has the website as origin. It's a backend origin. And looking at it, I'm looking at this endpoint. This is a front door endpoint that has been configured for this particular origin, which is the website. So this is the private link demo app, azurewebsites.net. This is the actual website that is getting protected. And we can also see that the security policy has been assigned to this particular for this particular website by using this Azure WAF policy, which is integrated with front door. You can see that the policy mode is in prevention mode, so it will block SQL injection attacks. And then we can go to the manage rules section. And here you can see that we have got bot manager rule set 1.0, which protects against malicious bots, as well as the default rule set 2.1, and they're all set in their default status. Now I want to show you the actual web app. This is the web application that is protected by private link. So if I try to access it over the internet, I get a 403 forbidden error because of the private link. It does not have access from the internet. But if I go to this endpoint, this is the private endpoint which is protecting the backend, and I try to access it, this endpoint, I do see a response. This is a picture that is coming from within the web application, which is inside the private link. So now let's see how WAF is protecting against a SQL injection attack. Now what I'm going to try to do is I'm going to try to access the same front-end endpoint, but with a SQL injection query. And I get request is blocked. And this is how WAF is protecting from a SQL injection attack. So now let's go back to my presentation. And we come to the knowledge check section. So let's get started. You can use your phones to look at the QR code and try to answer this question. We'll have 1 minute to complete this question. Basically, we want to stop threat actors from submitting malicious requests to the web application. Which mode should the company use? Okay, so it looks like we have the answer. The answer is 500% of the users answered correctly. So prevention mode, that is the mode where we should make sure that the WAF is to protect against malicious requests. Next question. Suppose a company wants to deploy a WAF to protect web application that accepts user data from a form. Which of the following best describes how Azure WAF protects the app?
Interesting question. Let's see what our users are saying.
Okay, so now let's see the answer. So sanitizing input is the right answer. So this sanitizing input refers to removing or disabling dangerous text elements from an input. So that is the right answer. Last question. Suppose a company wants to deploy a web app and is trying to decide whether to use in-house developers to code against common exploits. Which of the following scenario isn't a favor of using WAF? So basically trying to understand under what scenario you may not want to have a WAF.
Let's go, guys. Come on. Vote, please vote. Interesting. There is a battle.
Okay, so the correct answer is B. So whenever there's a web application that is inside your private network connection, it is already protected from the internet and the traffic never goes over to the public internet. It makes sense in those scenarios. There's no need to protect against web attacks. So thank you for voting. And finally, I would like to summarize what we talked today. We talked about the distributed denial of service attack components. We looked at the differences between Azure DDoS infrastructure protection and Azure DDoS protection. We looked at the rapid response and other best practices. We also understood how Azure WAF works to protect against known threats, and we identified if WAF is the right solution for your scenarios. So
Soumya, we have a few minutes more. If you finish, maybe we can take. I see one question for me. So there's a question from YouTube. The Window Geek is asking on DDoS protection service. What if I was practicing to do DDoS attack on my cloud machine? Is that wrong? So yes, it's not. It's prohibited. We allow simulation of DDoS attacks only only using one of our DDoS simulation partners. We have three of those, and you can go to our DDoS protection service, doc website and see who they are. I demoed Ixia Breaking Point Clown. This is one of them. Obviously, if someone tries to launch either a simulation or an offensive DDoS attack, it doesn't really matter if it's from within Azure, like from one region to another, or from the internet to a resource in Azure. Will automatically detect and mitigate the attack, so our customers are protected by the infrastructure protection service, or for those that select DDoS network protection SKU, they will get protected by it as well. So bottom line, yes, it's prohibited. It's against the DDoS protection terms of use, and customers should use our simulation partners.
Do we have any other questions, Samir?
No, I don't think so. I don't see any more.
Okay.
Yeah, so I think with that, we've kind of finished our Learn Live session. It was a great experience. Thank you, Somwa, for doing it together. Was pleasure. And everybody, we hope you enjoyed it. And thank you for your time on Learn Live.
Thank you, Amir. It was amazing to work with you and have this Learn Live session. And just for you audiences, we still have a few more uh, interactive learning exercises on this in this link. And I want to talk about just highlight that we have got another one coming up on March 23rd, which is protect your virtual machines by using Azure Backup.
Thank you.
Thanks, everyone. Bye.
Bye bye.